Elasticity of scale is basically the percentage change or percentage increase in output due to 1% increase in all inputs. Suppose there are two inputs, labor and capital, and if labor and capital both increases by 1%, both labor and capital has increased by 1%, so my output has increased 20% or 20. So this 20% is basically our elasticity of scale. Due to 1% increase in labor and 1% increase in capital, our output has increased by 20%. So this 20% is elasticity of scale, or 20 is basically the value of elasticity of scale. So what actually elasticity of tries to tell us? Elasticity of scale tries to tell us the percentage increase in output, that is 20, due to 1% increase in all the inputs, that is 1% increase in labor and 1% increase in capital. It can also contain other factors of production. I just tried to give a example of what it actually tries to tell by this method. Now, elasticity of scale. What is the formula of elasticity of scale? Formula of elasticity of scale is, at first, elasticity of scale is denoted by E of x. E of x is basically the terminology used for elasticity of scale. It can be written as differentiation of y of t. Y of t, we have to differentiate y of t with respect to t into t by y. That is the formula of elasticity of scale. Now at first take me a function of y, that is x1 to the power a x into x2 to the power b. If we want to differentiate this function, at first we have to convert, or at first we have to increase the input by t proportion. So if we want to increase the input by t proportion, then we have to find out y of t. What is y of t? Y of t is basically increasing the x1 input by t proportion, then increasing the x2 input by t proportion. If we increase the x1 input by t proportion, then we can write x1 to the power a into t to the power a into, if we again want to increase the x2 input in t proportion, then we may write x2 to the power b into x2 to the power t to the power b, increasing the x2 input by t proportion. So that has now become x1 to the power a into x2 to the power b, but t to the power a and t to the power b is supposed to be t to the power a plus b, because bases are equal, so powers are supposed to be added. Now this is the value of yt. So we have to differentiate this yt or y of t with respect to dt, or with respect to t. So what will we get when we try to differentiate this with respect to t? This part will not have any derivative. This part will be separated because it doesn't has the term t in it. So this part will be separated. So let me write this part at first. x1 to the power a into x2 to the power b. Into x2 to the power b. Now for this part, t to the power a plus b, this part will be differentiated with respect to t. So a plus b will come before, and it will be a plus b, and 1 will be subtracted from the power, that will be t to the power a plus b minus 1. So what is elasticity of scale? Elasticity of scale is basically differentiation of yt with respect to t into t by y. So let me write this differentiation of yt with respect to t is basically this term. So let me write this term, x1 to the power a into x2 to the power b into a plus b to the power into t to the power a plus b minus 1. This will be multiplied by t by y. Okay. Now let me write it again. X1 to the power a into x2 to the power b into t to the power into a plus b into t to the power a plus b minus 1 into t by y. Now as you can see, this part is basically y. Why is this part y? Because the function that we have obtained, the actual function is y is equal to x1 to the power a into x2 to the power b. So this part is basically y. So we can write y in the place of this. So we may write y into a plus b into t to the power a plus b minus 1 into t by y. This y and y will be gone. We will only have now a plus b into t to the power now this t and t has the common base, but powers are different. We have to add the powers. A plus b minus 1 plus 1. This t has the power of 1. So it has now become a plus b into t to the power a plus b. Now I am just writing the value. This is the value of elasticity of substitution for a function given as y is equal to x1 to the power a into x2 to the power b. This is the value of elasticity of substitution for this function. Now let me write the value. E of x is basically a plus b into t to the power a plus b. We will consider three cases. If t is equal to 1, what will happen? If t greater than 1, what will happen? If t is less than 1, then what will happen? So if t is equal to 1, then we will get e to the power x. Just put on here. So this will now become 1 to the power a plus b. Anything 1 to the power anything is basically 1. 1 to the power 5 is 1. 1 to the power 17 is 1. 1 to the power anything is 1. So 1 to the power a plus b will also be 1. So this part has become 1 now if t is equal to 1. So only remaining part is a plus b. So the elasticity of scale is a plus b if t is equal to 1. That means we are not scaling up. If t is equal to 1, then we are not scaling up, we are not scaling down. That means we are not scaling our production up, or we are not scaling our production down. We are basically being at the current scale of operation, and we are basically being constant in the scale of operation. If t greater than 1, then we are scaling up. I am not suppose t greater than 1 means suppose t is equal to 2 or t is equal to 3. So if we assume that t is equal to 3, then it will become a plus b into 3 to the power a plus b. So in case of t greater than 1, we are actually scaling up. That means we are increasing our production and we are scaling operation up. And in case of t less than 1, that means t can be 0. So if t can be 0, then the elasticity of scale can turn into 0. Okay, that means we are scaling down. Because if t is 0, then 0 to the power anything, 0 to the power anything is 0. So, and 0 multiplied by a plus b will also be 0. So elasticity of scale is 0, and we are scaling down in this case. We are scaling down, that means we are decreasing our operation. So this is basically elasticity of scale and the cases of elasticity of scale. Suppose a function is given as y is equal to x1 alpha into x2 to the power 1 minus alpha. You can easily determine the value of elasticity of substitution, elasticity of scale for this type of functions. Now, at first you have to derive the y of t. Suppose a function is given as y is equal to x1 to the power alpha into x2 to the power 1 minus alpha. So you have to derive y of t. What will be y of t? Y of t will be x1 to the power alpha into t to the power alpha into x2 to the power 1 minus alpha into t to the power 1 minus alpha. So now differentiate this with respect to t. What will we get? we will get x1 to the power alpha into x2 to the power 1 minus alpha, but this t alpha and t to the power 1 minus alpha has now become only t, because the bases are equal, so power will be obtained. Okay, so in this way you can derive the function. So only t to the power 1 has obtained, because we have t to the power alpha plus 1 minus alpha, so alpha minus alpha will be gone, only 1 will remain, so t is only there, and if we do the derivative of t with respect to t, then we will get only 1. So the function has now become x1 to the power alpha, x2 to the power 1 minus alpha. Now if we try to write down the formula of elasticity of scale, then that is E of x is equal to derivative of yt with respect to t into t by y. So basically what we have obtained, the value of the derivative is basically x1 to the power alpha, x2 to the power 1 minus alpha. So x1 to the power alpha into x2 to the power 1 minus alpha into t by y. This is basically our y, because the function was given as y is equal to x1 alpha into x2 to the power 1 minus alpha. So this is basically y. We will write it as y into t by y will cut. So we are getting the value of t only. T is the elasticity of scale. If t is equal to 1, then we are getting the elasticity of scale at current. If t is greater than 1, then we are getting the elasticity of scale, that is scaling up, less than 1, we are getting to the scaling down of the elasticity of scale, or we are scaling down the production. So that is basically obtained here. All of it depends on the value of t.